Apollo versus the Black Market, the Team Leonis presentation for IST 454 Cyber Forensics with Dr. Gerry Santoro. The mobile phone is a ubiquitous technology in today's world. In fact, nearly 9 out of every 10 Americans own a device capable of retrieving, sending, and storing data from the palm of their hand. It has become a social norm to utilize mobile devices for our day-to-day lives, and therefore most of our correspondence has now transformed into a series of digital exchanges of information. This information is stored for the convenience of the user. However, there are several security and privacy concerns. With the newest mobile forensics technology, examiners now have the ability to peer into not only the user's identity, but also the time, location, and sometimes topic of discussion he or she may have had on their device. Through the use of several mobile device forensics tools, this lab will cover the following topics: evidence acquisition, preservation of random access memory or RAM and other temporary data, device imaging, limitations of current technology, scope of investigation. We will review the procedures step by step and discuss some challenges that mobile forensics faces, including difficulty with live acquisitions, removable storage media such as a SIM card, remote wiping of a device, and more. And finally, we will touch on the Dzarsky method. Consider a scenario where you are assigned as an authorized requester for a major financial institution, Leonis Inc. You've been given the responsibility to investigate an employee who has been accused of mishandling and sharing trade secrets with competing corporations by transmitting one or more files via their personal iPhone 3GS. Company policy states that under no condition shall an employee transfer or recreate any data onto a personal portable electronic device. Furthermore, any device that is connected to the company network without prior written consent by an executive administrator is subject to investigation and confiscation. The employee, knowing that they may be caught for wrongdoing, secretly erases all data from the phone and reformats the hard drive just minutes before the device is confiscated. However, while performing this function, the device was automatically backed up in iTunes on their work computer. Using the iTunes backup, you need to determine the legitimacy of these accusations and report your findings.
To perform this lab, you'll need a Windows-based PC operating version XP or higher. Let's get started. Open iBackup Bot located on the desktop. As the program opens, it will automatically search all file folders for iPhone backups. Click on the suspect's backup. If there are more, you will need to reperform the following steps for all backups. Click File and Duplicate. Locate your forensic evidence disk drive and save the duplicate copy by clicking Select Folder. Once you have successfully saved the backup copy to your forensic evidence disk drive, open a command prompt with administrator rights. We will now verify the backup copy is a one-for-one duplicate of the original iPhone backup. To do this, we will use Microsoft's File Checksum Integrity Verifier. Type cd/FCIV. This command loads the program. Next, type fciv.exe to observe the function commands. Start by creating a hash directory of the backup copy. Type fciv.exe-add. Specify your backup copy file location. Type -wp and again specify the same file location. Finally, type -xml and specify an easy-to-find file path located within your forensic disk drive. Label your XML file case_hash.xml. Next, we'll verify the hash database is an exact match with the original backup. To do this, type fciv.exe-v-bp. Locate and enter the original file path on the suspect's machine. Type -xml and enter the hash database file path. The verification should take several seconds to complete. If all files are successfully verified, move on to the next step. Open Autopsy on your forensic workstation. Click on New Case and enter a relevant case name. Your case number will be 2014_0001. Enter your name under Examiner and click Finish. You will now be prompted to add source data to the case. Select Logical Files and click Browse. Search for your backup copy located on the forensic disk drive. Once you've added all backup copies, click Next. Select All Ingest Modules. These will automatically perform an analysis using various forensic techniques on your backup files. Click Next. The program will now ingest all files associated with the backup copies. You can view these files individually, nested under Data Sources in Logical File Set 1. Manually browse through each file and note any suspicious file names or anomalies. Click on Results and Extracted Content. Here, you will find a breakdown of the different search tools offered by Autopsy. Because the iPhone used the hierarchical file system, some functionality may be lost with these tools. Scroll through the retrieved media and note any suspicious content. Log the source file and metadata associated with any files you find in your investigation. You may also perform keyword searches by typing in the upper left-hand search bar. Try to think of any terms related to the case or evidence you have uncovered. Also, don't forget to switch between views. Finally, Autopsy will automatically calculate and save the MD5 hash of all ingested files so that you can safely investigate without concern of tampering. These hash values should also align with the hash directory created using Microsoft's FCIV tool.
Apple iOS devices are very powerful mobile computers with large amounts of volatile memory and persistent storage, either flash or solid-state drives. Unlike a typical personal computer, they are difficult to disassemble even on a forensic lab workbench. It is not feasible to remove the storage subsystem from an iOS device and connect it to a forensic workstation with a write blocker attached as we would with any other PC or laptop. Current iOS devices no longer contain SIM cards, which could be removed and examined offline. A physical image of the device storage media or SIM card would allow the examiner to retrieve deleted data from the Apple HFS Plus file system and is the preferred forensic examination method, though a logical backup of an iOS device contains a plethora of valuable information. The Apple firmware and iOS are closed source, though they have been reverse engineered by hackers for both good and evil ends. Commercial iOS forensic tools, as well as the Zdarsky method, do not entail jailbreaking the iOS device, but they benefit from the knowledge and methods used by Apple's hacker community. Live acquisitions are difficult with iOS devices. We did not explore key lockers or similar tools for our proposed hands-on lab to remotely capture the subject's live use of the device, but we suspect those tools exist. Both Access Data NPS Plus and the Zdarsky method require rebooting the device to perform the forensic imaging of its storage. While RAM contents will be lost, a surprising amount of user input data is persistent, such as text messages and web browsing history. While outside the scope of our proposed hands-on lab, a Faraday cage or similar means, such as multi-layered anti-static bags, to prevent remote wiping of the device are essential for real-world applications, as iOS devices can be remotely managed and wiped. These devices will attempt to phone home, either using available 3G, 4G cellular network or 802.11 Wi-Fi networks connected to the Internet. Our proposed hands-on lab does not deal with device encryption, though our companion reading, iOS Forensic Methods, by Jonathan Zdarsky, discusses it. The recent advent of iOS devices with automatically enabled fingerprint encryption keys presents a challenge for forensic examiners, but as briefed in the class discussion, a fingerprint taken from the subject can be used to unlock these devices. Team Leonis tried mightily to obtain Jonathan Zdarsky's software toolkit. According to his O'Reilly webcast, he tightly controls his software and limits it to sworn law enforcement officers. He fears that his software will be stolen by commercial vendors. The Zdarsky method contains customized iOS boot images for the many various iPhone and iPad models. The boot image is loaded by tethering the device to a forensic workstation running iTunes and a customized version of the iLiberty device jailbreaking tool. By booting the phone into recovery mode, the phone will load the custom iOS firmware. This firmware contains a secure shell server for remote access, the Unix command dd for physical imaging of the device's file system, and the netcat software to transport the image to the forensic workstation. The forensic workstation must not have been used for previous cases, as there is significant contamination danger, as iTunes will attempt to write to the user data portion of the device if the iPhone is not first placed in recovery mode. Once booted from the custom iOS firmware, the iOS device is accessed over the forensic laboratory's wireless network. It bears repeating that this network must be tightly controlled and must not be able to reach the internet, as the iOS device will attempt to phone home and can be remotely programmed to wipe itself. The user data portion of an iOS device contains many SQLite databases of great interest to a forensic examiner, including call history, address and contacts, calendar entries, notes, SMS messages, photos, Wi-Fi hotspots to which the phone has been connected, GPS data, emails sent from the phone, web browsing history, and instant messaging. The SQLite databases can be examined with structured query language via the SQLite command line tool for Microsoft Windows and Unix operating systems. The integration of the iOS device with Apple iCloud is worthy of further research, particularly with the use of the fingerprint for federated access control, but this is outside the scope of our proposed hands-on lab. Commercial tools such as Access Data MPES Plus and FTS iExam are cost prohibitive for an IST digital forensics hands-on lab. Jonathan Zdarsky's toolkit is not publicly available, and while it is very well documented, it is a significant level of effort to duplicate his toolkit. One major challenge is building the customized recovery images for the various iOS devices and bundling onto the customized operating system the necessary forensic tools to image the user's data file system. An IST hands-on lab using SleuthKit Autopsy to examine an iOS device backup made with iTunes and iBackupBot for the logical software acquisition, combined with the Zdarsky and other readings to understand the various files stored on an iOS device, promises to offer an IST student a better understanding of the valuable data stored on these devices. Thank you.